bring this system, which designed by Dr. Daniel Leithinger and Sean Formers and a bunch of people in my team. And he's giving a talk, Daniel Leithinger later. And also, we started a big exhibition about radical atoms, which I want to touch later. Our research driven by the vision, how to think about future human-computer interaction materials, starting from graphical user interface, tangible, and radical atoms. But why we really come back here is art. Art provides new perspective that turns our gaze to a new horizon, beyond imagination of engineer to satisfy specification, or beyond scientists who make amazing publications. So that's the reason we create art. Alan Kay headhunted me with Nicholas 23 years ago in Atlanta. Alan Kay said the future is not to predict, but to invent, which I strongly resonate. And to do so, we need three things. One is envision. We have to dream up the futures. What kind of future we want to bring? But also with the embody, implement. We are builder, we are maker. Unless you make it, you can't communicate, you can test the ideas. Then we have to inspire people, otherwise nobody remember. To do so, art plays very critical roles. To come up with a new question which nobody ever asked, art and philosophy really helps. Also to embody, of course, we have to speak all the language of the fabrications, computer engineering, electronics, design, and of course basic science. But also to inspire, to bring the expression to level, to make people think, move, we have to bring the art. Bio is a new digital, is a very powerful message that Nicolas Negroponte said 2 years ago. Then my team, including Jifeo, did this project called Biologic, creating a new second skin, breathing skin, using bacteria. Sweat drives the actuations driven by the millions of the bacteria, Bacillus substitunatus. Each flap contains living bacteria. Now we're zooming in. So these bacteria works as a relative humidity sensor and actuators. It's a totally new paradigm using biological science, also science to combine with design and art. So basically bio become a new interface. Instead of human-machine interface, human living machine interface with environment. So we really care about how to exhibit, how to communicate those ideas. That's the reason we really take exhibition seriously. So this is a steamboat steaming to the biological fabric, which hope you saw last year. This is a real-time movement. So this is a basic element to make this transformation. This is bio, nature. God provided an amazing system which allows to cultivate these bacteria. They human beings, skin. This skin breathes. This is a mannequin you can see in Ars Electronica centers, but it's not beautiful enough. The most beautiful thing is the people in motion. So we collaborated with the Boston Ballet dancers to wear, and they become aware of breathing skin because airflow changes. Then they customize the way to dance with bacteria. So this is the 30th anniversary of MIT Media Lab, and we are very lucky that 22 years ago, I had the first big exhibition, NTT ICC. Then, how many people remember this building? Do you know what it is? This is Ars Electronica Centers, 22 years ago. And we had a first big exhibition called Get in Touch, all about tangible bits. But great thing is last year, Gerfried Stocker took radical atoms as a new umbrellas. So this is a biologic. I just showed the video. You can see it. Also, great part is I can bring all my team, students, and the colleagues, then share all the excitement. These are also stuff that we showed last year, but the many stuff is continuing. The good thing is we could extend this exhibition to bring new pieces to the Ars Electronica Center, second floors. So this is a new room that our team, Jifei and Nicholas and I, worked together with Daniel to design a week ago. So in these new rooms, you see 3 new radical atoms, new materials called kinetics and the Cilia and aeromorph. All this project was led by Jifei Oh, he's a PhD candidate of TMG. He's going to talk right after that. And this is a cool signage of elevator. You see second floor is radical atoms. Hope you don't miss it. And but the most important thing is cross-fertilization between art, science, design, technology. One thing is to pick one. I'm an artist, or I'm an engineer. That's the end of the world. You have to speak all the language. You have to translate your idea to all the 4 dimensions. Otherwise, you cannot really cross the boundary or bar. So that's the reason I really strongly believe transdisciplinary is key. And also main theme of these sessions. So let me read. Finding opportunity in conflict between disciplines. Breaking down old paradigm to create new archetype. Turning our gaze towards newfound horizons in the universe. So hope you can get some stimuli from all the speakers' presentation of the experience, how to really cross the boundary, how to break the wall. But also, we kept some enough time of the Q&A and discussion. We really want to learn from you guys. Many people have amazing experiences. I stay all night today, so hope we hear a lot of the feedback from you guys. So now, I'd like to start the session of art science from vision to practice. First speaker is Jifei Oh. He's a PhD candidate of Tanjung Media Group, and he's responsible for the 4 projects in the new room, including biologic, Syria, kinetics, and aeromorph. So, thank you.
Also, can I use this?
Yes, you can use it. This adapter here.
Oh, okay.
And if you need some sound.
I don't need sound.
You need no sound?
I don't need sound. So I just need a microphone.
Okay. I'll bring you one.
Just waiting for a microphone. Thank you. Thank you, Hiroshi. Thanks for the introduction. My name is Jifei. I'm a PhD student in Hiroshi's group. And I think even being there at MIT as Hiroshi's student and also being here at Ars Electronica, still find it very hard and scared to talk about art and science, mainly because I'm a trained designer. And so I think today I will provide some perspective about a design practice of art and science. Because of the use of the word of the design is very general, and I think for me, when we're talking about design, usually we're talking about designing shapes and what kind of geometry you're operating on, and also the rules, how you connect all the geometry together, and what kind of tools you can create in order to embody all this kind of design that you have. So basically, that's like a general frame that I have for most of the project that we did, and with this kind of a frame, we were thinking about designing new materials, right? Like the material, a lot of people are talking about future of materials, and we're thinking about how can we design the material that can change properties. In this case, we designed a chair that basically can changing from a carpet to a table, or a chair that you can, or bench people can sit on. We're thinking about how to design a transformable lamp that can turn from a rope switch, and then when you pull it and you roll up back, become a lampshade, and then light up, become like an energy light-saving light bulb shape. And we're thinking about how can we design a future of a packaging material where the air cushion is actually will deform the package itself, where it holds the item that you want to ship. And we're thinking about how we can design the future of fabric that can respond to your body. This is the biologic project where we use the bacteria putting on your body, and the bacteria will swell and shrink based on your sweat. Last but not least, which is a pretty recent project, we're thinking about how can we design and fabricate super thin hair structure, and then use those hair structure as a actuator for robotics, and also as a sensor. When you touch it, it can tell you what direction you are touching it, and also what's the speed of you are touching it. So those are all like some of the examples we're thinking about. How can we design the future, design the material, and make it to become a more responsive and dynamic. And today, I think I want to give a more concrete example, which we haven't talked about in last year in Ars Electronica. It's called Aeromorph. So this project is basically investigating how can we create a transformable sheets material by inflation. And then the inspiration is actually coming from two fields. One is like the inflatable architecture, where people are really thinking about how to create those kind of like a balloon that like by its own volumetric shape and create a different aesthetic, and it creates this kind of like a lightweight and deployable architecture structure. And then the other inspiration is coming actually from origami, from the paper folding, right? Like it's a very powerful technique where we can translate a sheets material into 3 dimensions. So the question coming together is like, how can we create a inflatable structure that can fold like origami, right? So this is the simple mechanism that we introduced, and then with this mechanism that we will go through that, how through this mechanism we can create all sorts of different transformations. And in order to create those transformations, we also need to design different tools, different software to facilitate that. And so we can start with the basic geometry, right? Like how does this work? So if we think about a simple non-extensible sheets fabric or paper, and then if you make an airbag with it as a square, and I think most people would notice that when you inflate it, the edges of the square will start to shrink, and then because the air tend to inflate isotropically, and then causing that kind of like curves on the edges. And then what's interesting is that if you put 2 of them together and then having them share a seam together, and then they will start to bend together, that's because the material is not extensible, so that when you inflate it, they will try to keep the distance between the 2 airbags, and then therefore there's no other way. They have to basically fold up into the shape like this. On the right side, you can see the side section of this material, how when you inflate it, you start to bend. And then so we start to investigating how different kind of a hinge geometry will affect this bending angle. So we started thinking about how to, by changing the length of a line, you can basically control how much bending angle it will be. And then we can create different arcs. By changing the diameter of the arc, you can also control that. And then in the end, we come up with this shape of which we call a diamond, by like controlling the width of the diamond, and you can controlling the bending angle. And with that, we basically run this experiment together. As you can see from the screen, that when you're changing the width of this diamond shape, you can get this air pouch. When you inflate it, it will start to fold at a pretty accurate angle as you designed it. And then we take it one step further. Is like, how can we mathematically model this kind of a transformation, right? So basically, if we look at this kind of like a shape, that we will know that in order to calculate the angle between the line A and the line B by the cosine law, we need to, so basically we know that the W is fixed, so we just need to know like what changes with the A and B. And together with a collaborator in CCL at MIT, we actually run the finite element method to figure out how much shrinkage of the airbag would have when you inflate it, and it designed this kind of like a simulation design tool that for designers and engineers, when you import different meshes in this environment, and then you can simulate and also the different hinges, and you can simulate how this shape will transform in the end. And what also most importantly thing is that with this kind of like a tools, you can export whatever design you have to a digital fabrication tool, which we're going to talk about in the later. And then so now we have the geometries, we have the tools, software tools we can simulate, and now we can think about, you know, what kind of a crazy transformation you can make, what kind of like a new shape-changing materials you can make with this method. So here you see that at A is the design you have, and B is the simulation with the software, and C is the actual fabricated material, right? Like you can see that we can simply create a air pouch. When you inflate it, it starts to curl up. And then similarly, you can basically create other different transformation by given different like a hinge geometry and different arrangement. So that's what we're talking about, the geometry and the rules, right? And then so and again, like the elegant part of this is not any other like composite material usually you will see in the soft robotics, right? Like this is just one sheet, one like airbag that basically by varying how you arranging those hinges, you can get different transformation. And then because it's a thin and easy to fabricate, we can also composite like multiple back together to create this kind of like a sequential different transformation where a circle can transform into a square and back into a triangle. So like beyond the stripe, then when we arrange those kind of like a diamond shape together, and then we can get this sheets material start to bend instead of instead of folding. Like you can get like a more like a continuously nice curve when you inflate it. And then again, so by arranging those diamonds into different shapes, you can make them curl diagonally, or even create this kind of a hyperbolic structure, which usually you see in the Pringle, the potato chip shape. And for some people, then they are wondering, like, you know, what if I don't want to create this kind of like a folding or transformation, right? Like, then one way you can do is that we can create this kind of like a uniformal, like a cross ceiling hinges, so that when you inflate it, you create those kind of like a tiny, small, nice texture that pulses like a heartbeat, and then we actually use this mechanism to design some of those haptic devices we're gonna show later. So that's what we're talking about sheets. And then we're taking one step further, like what about a more expressive three-dimensional geometry? So this is a cube, a polygon that when you basically put the hinges at the, you know, where the hinge of the cubes, and then calculate what's the width of it, and then when you inflate it, they will all nicely fold into 90-degree and then create this kind of like a cubic shape. And then this is some more other complicated example where you see a ring will basically fold up into a truss structure, and a sheets of this kind of like stripe together, and then when you inflate it, it will basically fold it into a interlocked cubic shape. And then we can think about, like, you know, through this is one example for people can think about, like, with this mechanism, like what kind of, like, you know, different kind of transformation, a more complex transformation you can create with that. And I think for me, what more interesting thing is that because this mechanism is so robust, and we can actually already start to, when you create a shape, instead of laying it flat and inflate it, you can already just wrap it into a smaller pocket. In this case, we just wrap it into a like, you know, like an air pocket, and when you inflate it, it will pop up all this constraint and then restore the shape that you design and program with it. And I think this is very interesting because when I was a kid, I always read this manga called the Dragon Ball from Japan, and then in this there's this capsule where you throw it and it will basically become big and into become like a tent or something. And I think this is one of the way we can think about, you know, this might be a way we could, you know, like turn this kind of like a fictional world into the real by designing, you know, by the way of design. So after this, like a lot of people like started asking us, you know, how did you guys make those things? Like, and actually, to be honest, it's pretty straightforward and easy to make. And so we actually went through something from like, you know, a very crafty way where we manually create, you know, get those kind of like a heat sealable fabric, and then use the heat sealer that you can buy in the market, and then to basically manually create those air pockets. And then from 1 to 1,000, like we actually hired a lot of undergrads to make those kind of like collections. It's pretty much like a sweatshop. And then we're like, okay, actually we need to think about something a little bit smarter. And then that's how we come up with a second approach where we basically designing this kind of metal stand. And then in this metal stand, you can precisely control the hinge geometry, and then when you basically use a heat press and then put in this the stencil inside and press it, and then you can basically get the shape. So it's a very precise way of doing that, and also mass producible. So with that, we actually really went through a lot of like different geometries and different shapes with that. But one of the drawbacks is not very flexible. For every design you have, you really need to go through, you know, the water jet to make this stencil. And then that's how we end up to a more like a digital fabrication tool, where we made this a CNC router gantry. And on top of that, we put a heat sealer, solder iron, and then we changed the solder iron tip into a ball bearing, and I add some of like this kind of like a damping mechanism, so that that's Nicholas in the video, and so that basically when we turn on the heat, and then so this machine will basically do create all this kind of like shape that you saw, and then nicely like with this method. And then we also put a knife module on it, so that after you seal it, you can also nicely cut it, and then in order to get this final shape. So basically, it's like, as I said, like, you know, it's like we had this kind of like design of the geometries. We have the rules, how we assemble them together to create a transformation, and now we also design the tools that facilitate us to create this kind of like different transformation. And in the end, with this kind of tools, we tried all sorts of different materials, and then really to see that, hey, it's not just the heat sealable fabric, it can work like that, you know, all of these materials. And then we also like documented what kind of like a printing parameters you need, and then in order to make those airbags. And then suddenly this kind of knowledge become transferable, right? Like you can take these sheets and then make this kind of like a robotic gantry to make all this transformable material by yourself. And actually right now, the Pratt Institute Architecture Department is actually literally taking this method in their course for the architecture student to design, you know, deployable, transformable structures. So I think it is like very valuable to see something that, you know, we started with as a design idea, and then they become a transferable knowledge for the other domain to use. And then so we also like thinking about how this kind of things can be used for something, you know, meaningful, like in the design interaction design application. So this is a glove we designed it for like to think about how can you use this kind of like a haptic feedback for a bicycle, where it tells you the GPS information, turning left or turning right, and then by instead of like showing from the pixel, it's showing from the little airbag by pausing it to tell you that. And then we also thinking about, this is the example you saw, that we can design this kind of like an airbag that folds up and then to become like a package and things like that. I think I'm running out of time. So basically those are like the applications, right? Like, and I think if we look back, all this project we did in the tangible media group, and which we call it programmable material, you actually gonna see this in the exhibition at the Ars Electronica Center with some of the, you know, the Aeromorph project, the Celia, and also the Neo Kinetics project. So it's always thinking about like how can you again, of course, when you look at this picture, right, like you see that all these projects use different method, and then they all operate at a different length scale, but also we're really interested about this idea, like how can you bring the human experience close to the design of the material. And then if you look at right now the development in the material science, that if you look at this bar scale chart, is that a lot of new material invention is really to the scale that a human cannot perceive at all. It's like at a nano scale. But again, like a human with the body, we still like, our experience is still based on how, you know, our like body scale. And then so I think this really provides an opportunity for design to think about how you can operate at a scale where you can bring in the human experience close to the engineering material. And this is really back to the topic we're talking about. On the one side is the science, and on the other side is the art. And I really think the design is a powerful tool to bring the science and the art together. And thank you very much. If you have questions, it's my email.
Thank you, Jifeo. So you have to go to airport.
Yes.
Okay. MIT is very rigid about the class we have to start. So Jifeo have to fly back from Linz to Boston to make MIT missions. So it's a great pleasure to having introduced Professor Joachim Sauter he has been amazing models for all of us to accomplish highest levels of the design, technology, and the artistic stuff. And he's an award winner and so many stuff. But maybe it's much better to let himself, Professor Joachim Sauter, to talk about his view about art science. Joachim.
So, are there any slides already? No.
Plug it up and on again.
The other one.
No.
Yeah.
Yeah.
Okay. Thanks a lot. So Hiroshi, thanks for inviting me for a second time in a row. It seems that we have a lot of shared interest, especially the ones of this year, the cross-fertilization, as it said in the catalog, cross-fertilization between art design and technology. So when we founded ART+COM 30 years ago to research the upcoming digital, we already had been artists, designers, technicians, programmers, hackers, and actually since that time we are working in this interdisciplinary tension between art design and digital technologies. And if you look on our website nowadays, you actually see these three disciplines. So we are doing media art, media communication design, and media research. In media art, we are mainly doing commissioned work by institutions, by private collectors, or self-commissioned work. In the communication field, we are doing a lot of installations for museums, for exhibitions. And in the research field, we are doing commissioned research for institutions, but also for the industry. And again, as in all two other disciplines, we are defining our own topics and topics of interest. And I selected two research topics to show this kind of cross-fertilization between these other two disciplines. This is on one hand computational reflectives. It's a research topic in which we try to define or develop material which allows us to communicate with light and reflections. And computational kinetics, it's a field in which we try to find principles, ideas, processes to transfer the virtual, or let's say the computation from the virtual into the physical space. And I want to start with the computational reflectives. As said, here we try to find principles, how to encode information into material which then can be decoded by light. Funny enough, it starts with a design commission. So some years ago, we got a nice commission by the Deutsche Bank to do let's say a piece, an installation in front of their art collection. So they have one of the hugest art collections in Germany, and they asked us to do so. And the only condition was to use their logo. So I like this very much. It's done by my late mentor, Anton Stankowski, in the 70s, but I'm not here to make three-dimensional logos in space. So what we did, we designed a computationally organized mirror surface, and we have a blue light on the rear. And if you are in the right standpoint, you are seeing the logo for a millisecond. So the logo is there, but it's also not there. It's encoded in the material. So this is the installation. So you see this mirrored thing, and then on the other hand, the blue light. So you're going up the stairs, and you only see the scattered blue polygons reflecting the blue light. And at the end, there is, for a short moment of time, you see the logo. So we found that so interesting that we said, okay, let's make research about these computational reflectives, and started to invest a little bit. So the motivation at the very beginning was a design piece, and then we did research how we can more or less bring this further. And we went into caustic reflections. So there are a lot of artists doing caustic reflections, mainly by modulating water, and then you have these chaotic reflections here, or having a material which is modulated by the viewers and create a kind of chaotic caustic reflections. But we wanted to get a step further and control the caustic reflections. So the basic idea was to create a three-dimensional surface in which we encode information, which then can be decoded by a light source. So this is the principle: you have a light source, and if you're in the red standpoint, instead of getting a chaotic caustic reflections, you suddenly can read something. So we encode information into this surface, which then can be decoded by using a light source. So this is what we did. So we computationally designed the surface, 3D milled it, silver coated it, and then we had this square meter of let's say frozen water, and encoded two letters into it. The Greek letters delta for distance or movement, and the Greek letter phi for light. And if the light source is on a certain point, delta can be read, and on another point, phi can be read, and in between there's a chaotic caustic reflection. Can we have sound? So we came from a design assignment, went into the research, and ended up with an art project which we did in Korea. It's a 25 square meter piece of a river in which we encoded attributes of rivers which we found in poems, and you can decode them then with a torch. Okay, coming from the computational reflectives now to the computational mechatronics. As said, this is a kind of research how to translate the computation from the physical into the from the virtual into the physical, and the first project is also dealing with mirrors, but it's more focusing on the computational mechatronics, and it's a research into the primary colors. So in the additive primary colors, as you all know, it's RGB, and if you add them, then you create a white light where you have all the visible spectrum of the light, and the subtractive primary colors, which is cyan, magenta, and yellow. If you print them over, you get black because you erase all wavelengths. The starting point of the project is a white light spot created out of RGB. So we have a red light, a green light, and a blue light, and this creates a white light. And if you are putting a mirror in between or in this light, then you are obviously reflect RGB in front, but magically enough, because to the shadows, you have cyan and magenta and yellow, the subtractive primary colors in the light spot. So very nice kind of findings, and we then put the mirror onto two motors, a bifilar mechatronic system, which allows us to move it around in space in one plane. And the whole installation was commissioned by Sonar in Barcelona, and they gave us a huge space, 50 by 20 by 17 meter. So we used 5 of these mirrors, and because it's a music festival, there was the opening concert by Olafur Arnalds, who also composed beforehand the music, sorry, the music for the installation. Yeah, this is a long-term exposure. You don't see this with your eyes, but it looks nice. Then we had a very nice space in Guangzhou, and you can see the RGB and CMYK according to the position of the mirror. And here we also added a white light for everyone who is in printing. That's now the K in CMYK. So we switched between the black and white mode and the color mode. And we then finally had an exhibition in Tokyo this year and finally did a documentation there. So you get a little impression about this. So I will end with a project which is a work in process, which we're actually doing in Singapore. And you have to apologize for the presentation. I put all the material I found together during my flight here. So it's a straightforward making of, but not till the end because it's not finished yet. I said it's a commission for the airport in Singapore for the new Terminal 4, which is a really difficult space. So it's a 300-meter space between, so this is the space between air side and land side. And they gave us a 200-meter long space there. And instead of doing a 200-meter installation, we decided to do 6 installations which are interacting with each other. These 6 pieces, they are divided in 16 sub-pieces, these beveled triangles, as you can see. And the whole installation is based on 2 mechatronic principles. One is the one you have seen before, the bifilar hanging of an object, which allows us to go up and down and left and right. And the second one is that we are asymmetrically hanging these beveled triangles. So the first element is hanging symmetrical, the next one is then tilted 20 degrees to the left, the next one again 20 degrees, and then it goes on and on. And this then creates this kind of shape, which allows us to do a whole variety of kind of figures, from a closed figure to a symmetrical to an open one to a chaotic one. And this is what you think at the beginning if you do a project, and then you start doing the test setup, and it turns out that it looks totally shitty. So things are shaking, the movements are not elegant, and actually this is more or less what I experience all the time. So the first moment you're doing it, you think, okay, come, forget the project and give the money back to the client. But then after a while, you then figure out how you solve the problems, and with some new hangings, we then achieved a quite elegant movement. And you already hear music because we again commissioned Olaf Arnalds to do music, and he's now doing the whole music for the airport. The whole goal was to create an installation which is a kind of poetic moment in a very lively space. And this was the starting point. And I have to say, after 2 years, you're not sure if you really achieved that. So the next step was the design of the object. And we decided to have an object which reflects the space from outside. So we silver-coated the outside, and which reflects itself from the inside. So it's this inside-outside reflective moment, and to support the inside reflection, we also added a LED string into the center of these objects, which also allows us to have a better communication between the objects, a better interaction between these objects by animating this. So we had a physical animation and the immaterial animation of the light. Yeah, you can imagine. So the next step is then simulating the whole thing. Is it really working? How are the reflections? How is it really fitting into space? Because we had to fill this 200 meters in a kind of meaningful way. And yes, it was okay. We were satisfied with these simulations, and then started to design the object by itself, the shape, the colors, the final things. And then we went into the choreography. So choreography always starts with off-the-shelf animation tool. But this is too mighty, and then we are always writing a kind of sketching tool. And at the end, it goes into the production tool, which is homemade, where we can computationally choreograph the whole thing, but also manually or music-driven. And there's then a kind of real-time preview, which allows us to judge the whole thing from different viewpoints. So the same with the hardware. Okay, this is then the last step where you analyze the data and give it to the motors. The same with the test setup. So this is the first one you had seen before. The second one is then a scale 1:1, where we translate this into 1:1. And at that moment, we give it out to a workshop, because this is nothing what you can do at home in your studio. And they also then develop the motors. The second step, then after half a year or so, you're going then into the final form and the final motor layout. And the third one is then the production. And you get the first element, and you have it in Germany. And finally, you can really bring both things together, the music, the choreography, and the physical thing. And also the poor guys, the mechatronic guys, had to wire 380 motors. But at the end, even if you have a lot of simulation, and even if you have a lot of test setup, it comes to a 1:1 piece at the end. And only then you can say, do you achieve the poetic quality you wanted to start with? So actually we are now in the process of setting up. 3 elements are already hanging, and I got the permission to show you 30 seconds of the material of 3 objects. And this is the final result. Okay, hopefully in end of October everything is ready. The opening of the airport will be then there. Coming to the end, and a final remark. If you go to our website, as you had seen before, you have these 3 doors. And even if you enter one of the doors, or all the 3 doors, you're always standing in the same space. So we don't have an art department, a communication department, or research department. So it's always the same space and the same people. And they are forced to work transdisciplinary, and they are forced to leave their comfort zone. I think this made us survive the last 30 years. Thank you.
Thank you. Thanks, Joachim. It's just so beautiful. But also behind the scene, how much effort, engineering, science happening is something also beautiful. So thanks to Joachim. And also, it's a great pleasure to invite another old, amazing friend in this community, media, Professor Christa Sommerer. Everybody knows because you are from Linz. And she actually grew up with Ars Electronica and every aspect of the media arts. And also Ars Electronica, she and her team has significant contributions. Also, many of you must have seen the interface culture exhibitions in universities. So I think she's one of the best person to talk about how this art can cross-fertilize with other disciplines to create the new digital cultures, new expressions. Christa?
Thank you very much.
Yeah. It's on? Not? Oh, yes, it's on. Great.
So, thank you very much, Hiroshi, for inviting us here. It's a big pleasure. As you said, we are here in Linz at the University of Art and Design running the Interface Cultures Department. Laurent Mignonneau, my long-term partner and also professor at the university, is here as well. And I would like to send a special greeting, I hope he's watching it, to Professor Itsuo Sakane. We just visited him 2 weeks ago in Japan, and I know that he's super interested in knowing what's going on here in Ars Electronica. So, dear Sakane-san, if you watch this by chance, we send you the best greetings from Austria, from Linz. And please do come back if your health allows it. So what I would like to do today, give you a few examples of art and technology synthesis by showing you some selected artworks that Laurent and me made over the years, and also show a bit the details of where this idea come from and how we go from concept to the technological development. Before I do this, I want to just, without being too scholarly or academic, but give you a few historical and recent references of art and technology synthesis. And then, as I said, show you some examples of our own recent art production and show you where this idea come from and how we realized them and how we use the technology in this case. If we look in the history of art and technology, I think there are so many, or history of art and science, there are so many examples of very famous and important artists, scientists, or scientists/artists, or artist engineers that really, as Hiroshi said in the entrance statements, went beyond the boundaries of their disciplines and really promoted a new field or created new fields that maybe years later became really dominant and shaped whole industries, but also the way we interact with the world. Experiments in art and technology, I think many people know it, was a great group in the 60s, 50s, 60s, where famous artists like Rauschenberg or Billy Kluwer, artists and scientists, Rauschenberg, Billy Kluwer, worked together on different performances where they really tried to push the boundaries of the technology, and actually later became also to be known, very important in art history. I don't have the time to go into it. But cybernetics and cybernetic art is another field that's really important for us here, especially standing in Linz in Ars Electronica, where artists and scientists, mostly scientists actually at that time, mathematicians or philosophers, starting to think about how the new technology or the communication between animal and machine can lead to new forms of ways of interacting with the world. And we were very happy to have Jascha Reinhardt here. I think it was 2 years ago at the Ars Electronica getting the Golden Nika Award for Life Achievement, because she was one of the first to actually understand this trend and put art and science and technology together by bringing important practitioners from that time to the Cybernetic Serendipity exhibition. Abraham Moles and Max Benze also were very influential for information aesthetics because they saw the potential of the computing technology and computer graphics. And it was mostly mathematicians and scientists who understood the first time the power of computing also for the arts and for digital arts. And I think today we have seen, of course, already fantastic examples of design works that came out of this form of information aesthetics. So Frida Nake, a pioneer, for example, in computer graphics, was actually or is a trained mathematician and computer scientist, but moved more and more into the arts, and now his artworks are really being sold in the art market, and people understood that this is a very important contribution also to the arts. Another interesting area is field was the Vienna Circle, actually here in Austria. That was a group of scientists / artists / philosophers that was circling around Otto Neurath, talking about a form of logical empirism and a kind of combination of natural and social sciences, and called for a unification of the sciences. So that was already something that I think we see happening today as well. And even people like Ludwig Wittgenstein and Frank Popper, philosophers, thinkers, have been contributing to this line of thinking. We were very lucky to actually have Hiroshi Ishii in a conference we did in the 1996 in ATR when Laurent and me were researching there. And this was a book that came out here, so it's a bit outdated, but still this was one of the contributions of art and science, and bringing artists and scientists together and see where in the future this type of collaboration would happen. I also would like to point out the Lashnia Center. I think Richard Kluszinski, I've seen him around, is putting up a very nice series of book presentations and also exhibitions in Poland, where he brings people, artists and scientists together to look at the different combinations that are possible. And another interesting thing I discovered recently when we did a research day at Tsukuba University, where Professor Hiro Iwata is teaching and putting up the Empowerment Informatics Studio, is the concept of Kansai engineering, a kind of new type of engineering that supports the improvement of everyday life quality, and also tries to bring in artists, scientists, people from the humanities, even from philosophy, to work together and propose a new type of engineering for the future. Enough theory, let's move on now by showing you some examples. The first project I want to show you, probably some of you have seen it in the Ars Electronica Center last year. It was, or was it 2 years ago? I'm getting a bit confused about the years. Was a project called Portrait on the Fly. It's an artwork, an interactive artwork that deals with self-portraiture, and we use the motif of the fly as an important element in this work. Why do we use the fly? Many people ask us, why do you always use flies? We find flies quite interesting because for us they are a symbol of decay. In many cultures, actually, the fly is something that people do not like. You know, who likes flies here? Oh, nobody? Oh, one person, yeah, Richard, Jill, yes, you like flies. Because of course, like for example, in forensic medicine, flies are used, the larvae of the flies are used to determine the exact time of the death of a body. Because from the development of the larvae, we can see when the body has died or when this animal or being has died, and then we can determine the exact time of death. What's also very interesting to us, coming from an art background, is the fly as a motif is a very important symbol in art history as well. I put you here one example of a Renaissance painting from Rachel Ruiz, a still life with flowers and fruits, and probably you have all been to art museums or art history museums and know those beautiful still lifes, but if you watch carefully, sometimes the painter has put in little like ugly insects in there. And this was done, of course, on purpose. And many of these meanings of these insects, especially flies, is a kind of memento mori, a kind of remembrance about transience and vanitas. Vanitas is, for example, an important topic in art history. So playing with this or implementing some concepts or motives of art history has become very important for us in the past. So even though people don't need to know this, intuitively they understand that fly is something unpleasant. It reminds them maybe of decay and decomposition. And we use this in the artworks, a portrait on the fly, where people just stand, it's quite technologically really simple, stand in front of a monitor. They see themselves composed of little flies. These flies start to appear and disappear and create a kind of animation, even though it's not an animation, it's actually a system that's developing and really creating itself on the fly, as you will see here in this video, where people start to see themselves displayed in a fly portrait, but as soon as they move, they disappear. So Laurent made this program with a kind of swarming algorithm that lets you experience your own self-portrait in a very immediate, but also very ephemeral way. And this was we observed it. It was very interesting to us to actually people completely fascinated by their own self-image. I know that many of you have mobile phones and, you know, taking pictures of yourself, selfie culture is something that I think very kind of relevant and very dominant in our culture right now. So this became a very interesting inspiration to us to continue with this self-portraiture. Before I move on to show you some more works, I would also like to point out that we became interested in the idea of keeping something more permanent. So we started to make print portraits of people that we found, mostly our friends actually, people from the art field, from media art, media science, and for example, Jascha Reinhardt, but also Hiroshi Ishii is part of our collection, and Richard Glushinsky and many others are part of the collection. So please go down in the basement, in the gallery space. There are portraits of people that we did with our Fly software, in a way also to remind about, you know, that we have this longing for something more permanent. And I think this is an expression, an artistic expression for it. This was the work Portrait on the Fly, and as I said, we became very interested in this idea of the self-image. Some people say that we live in a very narcissistic age, you know, people totally obsessed with themselves. You know, Kim Kardashian, or those people really very much deal with the self-image, promote the self-image, and it's all the attention that you create for yourself, and of course social media are a very important part of it. But on a psychological level, I think it's very interesting to look on also what this means in psychoanalysis. You know, where does this image of the self come from? So we started to read quite a lot in psychoanalysis, also try to transform this know-how into an artistic installation, and did some research about the Sigmund Freud, of course, who says, for example, that small children, and I think here probably there are many parents who observe this themselves, that small children are totally observed with themselves. They really see the world just through themselves. They're totally narcissistic, but not in a bad way, but it's a kind of narcissistic self, where they're occupied with themselves, and as the childs develop, only later they slowly start to understand the outside world and externalize their affections. So this shift from complete self-absorption to externalization of the self and trying to understand the others became something very interesting to us as an artistic concept. So from Jacques Lacan's concept of the mirror stage, where the mirror is the important element to actually externalize your own emotion and self-consciousness, this became an inspiration, and we wanted to go further with it. Mirror neurons, I think, is also another topic that we looked into from a conceptual level. Is insofar interesting that in mirror neurons, for example, it was discovered by Rizzolatti that monkeys, when they grab a banana, researchers could measure their brain activity and could exactly find out where this brain activity was taking place when the monkey grabbed the banana, and the same brain activity took place when they just observed other monkeys grabbing a banana or other people grabbing the banana. So this idea of the mirror neuron, I think, is very interesting because they are important for understanding feelings and emotions of other people or other living beings. So the image we have actually about others is very strongly influenced by the experiences that we made in child development, and also the image that we even understand the world is very strongly linked to mirror neurons. I know I'm leading to you maybe now through a lot of different concepts, but just to show you that all this ends up in one art project or artwork. For example, in the project we just did a couple of months ago for Itaú Cultural in Brazil, in an exhibition called Cybernetic Consciousness that took place in the Itaú Cultural. And we made a project called Neuro Mirror, where Laurent programmed a special avatar or algorithms, neural network, that lets you interact with your own self-image, but also with the image of this avatar. And what happens here, the person in the middle is yourself. You see yourself interacting in real time. The person on the left is yourself in a time delay. And the person on the right is a kind of alter ego or other self, a second self basically, that reacts to you, imitates you, but has his own neural network algorithms that interact with you and interpret and also modifies his behavior based on your own movement. So let's watch a small sequence here. So I'm entering here the scene. You see me interacting in real time in the middle. The interaction on the left side is a time delay, so that's, I think, well known. And the interaction on the right side is this avatar that is based, his behavior is based on a neural network algorithm, a bit similar like in the demos we have seen outside, or they're still on display here, that calculates his or her behavior based on the learning of the previous interactions that the interacting person is doing on site. It's a little complicated to explain, but if you try it out, you see actually that you're affecting that alter ego, and the alter ego also does his own thing. I know I have not so much time left, so I move quickly to the third example. It's completely new, was finished 2 weeks ago at the Empowerment Informatics Studio in Tsukuba University. And this is the largest encapsulated VR space in the world, 25 meters long, wide, 50 meters wide, 25 meters long. It's a VR space where you can immerse yourself with wearing special glasses. And what we did is come up with a concept that uses this feeling of immersion, but also with a slightly unpleasant and sort of artistic message that we wanted to convey. Our inspiration was the movie The Birds by Hitchcock. Probably many people have seen it. It's a very famous scene where those birds get out of control. They start to attack the villagers in that village somewhere in California, and start to attack the children, became extremely aggressive. So we wanted to create a similar feeling in an immersive environment, and also using again the motif of the fly, but this time a sort of monster fly that is very big and starts to fly around in this space. So what we did, Laurent, together with Hikaru Takatori and Professor Iwata, designed a special software for the VR environment where people can walk around. Huge flies are starting to swarm around them. They react to them. They immerse themselves into the space and start to really come towards you, attack you, but also by using a fan, you can get rid of them. So I show you here a sequence. We had actually the first test run was a school of children who came there, and it was a really Hitchcock moment when the first time these children interacted with these flies. So I show you a small sequence here. We also edit sound. Could we put the sound up a bit? So sound was really very loud. as a last remark, because Hiroshi asked us to sort of deal about also how do you go from concept to technology to art. So I hope to have been able to show that we have usually a long conceptual research phase where we take different inspirations, not just from art history, but also from science discourse, try to process or sort of, process this and turn it into an artwork by either inventing new technology or using existing technology, and also not put the technology just in the foreground, but really use the technology to convey an artistic concept in order to arouse a certain type of emotion, and I hope I showed this, a certain type of emotion in the visitor or in the person who participates in these installations. And also sometimes it happens that, maybe new technology is being invented and that could be used for other purposes as well. So we really do believe as artists, or as media artists, technology can appeal to the senses. Technological art can appeal to the senses, but it should be always carried by a strong artistic message. So that would be it. And I have one book here from the Art and Science for giveaway, so if anybody wants to have this. Hiroshi, okay. I will give it to you. So I hope we have time for discussion later, and that would be it from my point of view so far. Thank you.
Thank you. I think, can I get the microphone? It's really great to go back to the neuroscience, computer science, Nobel winner, to understand the fundamental principles of the machine or human being, then drive the art as she demonstrated. Is one of the very, very powerful approach. Thanks. Christa. Thank you. That's nice. So it's a great pleasure to introduce my old good friend, Shunji Yamanaka, and he's one of the leading professors and the designers. But most important thing is we met him actually here in 2001 when he was installing beautiful robots downstairs. Also, I was installing Get in Touch, Tangelbit's exhibit in the second floor. Since then, his approach, design was quite inspiring. Also hope many of you saw his Ready to Crawl and the other stuff in the Post City, this floor. So, Shunji Yamanaka.
Hello, everybody. First of all, I would like to say how honored I am to be here again. Thank you, Hiroshi, for visiting, for inviting me. And today, I would like to take this opportunity to introduce some of my research projects and prototypes talking about life-likeness and the designing behaviors of intelligent machines. As an industrial designer, I have designed many products. Fortunately, some of them were sold well in the global market, and some of them had gotten gold prizes of good design award. Also, I have continually designed and developed the prototypes with scientists or researchers based on the achievement of the advanced studies. Honorably, some of them are selected to permanent collection of the museums such as the New York MoMA and Ars Electronica Center. I have made several lifelike robots with researchers, and I would like to show some movies of that. Yes, this one. Cyclops is the first robot that I designed. It's a very lazy robot. The only thing it does is to stand. But actually, Cyclops has a special spherical joint in its metal spine, also artificial muscles driven by air pressure. And therefore, it is able to gently swivel and bend its torso. In addition, it has a built-in video camera on its head and is programmed to respond to the person's movement. When it senses someone, it follows that person with its gazing eye. Yes, this is the space. This space is the basement of Ars Electronica Center before renewal. Yeah, about 15 years ago. People danced and waved their hand in front of cyclops in an effort to gain attention of this machine. People feel that it has intelligence because they believe its gazing eye is an indicator of a robot perception or interest in them. Of course, it's an illusion in this machine. The next. A feeder has a specially stretchy fiber skin called lateral seamless wear and 12 arms of a pneumatic cylinder that moves back and forth slowly. The tips of each arm is fitted with a sensor so that when someone touches the tip, it quickly moves itself back, just like snail's tentacles. Ephira is a prototype to extract one of the typical reactions of some kind of primitive creature. The next, Ragiera, is a prototype of a new mechanical structure to get human perception of life movement. At first glance, it may look as though this robot has soft and flexible limbs, but in actuality, they are rigid structures made by hard materials. Recently, a great deal of research is being conducted to create soft robots by using motive energy and materials such as artificial muscles and flesh that more closely resemble those who living creatures. But Ragiera's mechanism is quite simple. Each of the bent cylindrical structure rotates in the direction it twists, empowered by motor with 3 units. The surface of them are precisely polished, and the gap of each part are very small. This cause an optical illusion. Its movement seems supple and smooth, as though it's made from soft materials. The audience sensed it like interactive, though in fact it had no sensor and moved randomly. Now it is exhibited at Volkswagen Museum in Berlin as a part of the Ars Electronica exhibitions. Next is apostrophe. Apostrophe is a prototype of a study of intrinsic behavior of living organisms. It was designed and developed by Mitsuru Muramatsu, Associate Researcher Ars, collaborated with Manfred Hirt, a German neuroscientist. Standing up and counteracting gravity is characteristic of living organisms, We fight gravity and stand on our feet, adapting the posture that puts the least strain on our body joint. In apostrophe, the joint contains a motor which is programmed to resist external force. These motors rotate in the opposite direction to the rotation caused by gravity. Apostrophe tried to lift its body in the same way as human beings stand up. The unique movement of apostrophe is a behavior of exploration to reach the point of stability. Like this. Much like a baby effort to stand up. Yeah. I would like to show you the newest 4 projects. Those are exhibited here. The first is Ready to Crawl. It includes 2 innovations for the future. The first is the possibility of all-in-one manufacturing preceded by additive manufacturing. Machines are usually completed by assembling parts which are manufactured in different ways and from different materials. But these robots are printed in just one piece made from one material using a laser sintering system from nylon powder. Put the motors and send electrons. It goes. It shows the future when we might have even a car just printed in one piece. And second is the possibility of designing a method based on free-form manufacturing. Those 3D printers had radically developed. Still, it is used for making a static object because it can be pointed out that additive manufacturing process now is inferior in accuracy. In fact, if we made traditional mechanisms such as gears or bearings, they do not work due to their rough surface. But we designed a new 3-dimensional structure for achieving lifelike movement beyond accuracy. Yes, this is a soft body, and inside this, soft driving shaft. The reason why this structure has never made it very simple. Any existing tooling process could not make them. Additive manufacturing, sometimes called free-form manufacturing, enables such sophisticated lifelike behavior instead of a precise moving. And this is a new one. It's a very small one. So cute, isn't it? Dislike? Far better than fries. Hiroshi Sugihara, a student of a laboratory in doctoral course, developed all of them. So, movement and the integrated structure. Yes, he's all talented. Next, al dente is a prototype to control object stiffness using a mathematical structure realized by additive manufacturing process. It is just developed by Kotaro Tanimichi, a master course student. Its spiral-shaped surface like a conoid has a geometrical axis in its center, but when printed as a structure, the geometrical axis doesn't work as structural beam. because its volume is approximately 0. As a result, it gets extremely flexible on one axis, but quite stiff on the other directions. The deformation can be controlled by the axis curve. By making it layered, wavy shape, it becomes a structure which can change its stiffness between rigid state and flexible state. Yeah, we feel a mysterious tactile impression on it we have never experienced because such a completely anisotropic material does not exist in nature. Through my experiences of making robots, my interest had become focused on developing robot elements that create the perception of lifelike or intelligent-like characteristics. People who touch or interact with my robots sense a primitive intelligence in them due to the robot reaction movement, even though these robots are not equipped with a complex system that could be said to be intellect. My approach to design these robots is to evolve lifelike action by taking existing natural element or movement and carefully minimize them in the future of the robot. The key is not to mimic the whole appearance of the natural action and to create, but to create only essential essence of what is needed for human perception. Sophisticated structure and subtle behavior of machines are keys for subconscious communication between widely socialized artificial intelligence and humans in future. Well, last year, the Institute of Industrial Science of the University of Tokyo has co-founded the Tokyo Design Lab with the Royal College of Art. Transparent intent is one of the results of the first 2-month trial project in the RCA-IIS Design Lab. The team led by Yuri Kribanov developed this prototype collaborated with Sauter Lab. Their research is a computer vision technology in which a normal camera is able to recognize objects and behaviors of the people captured by the system. We made 3 stories on it and exhibit here. The first step removes the tangible interface. The object is controlled through an action. The next step removes the need for the direct contact with the object by controlling the object with gaze and the gesture. We can start to control object with simply our intent. The final stage starts to explore the scenario what objects are clairvoyant. They control themselves based on human behavior. This is a basic prototype, quite primitive, but imagine an object or environment that could guess your intention by reading your subconscious behavior and adapt you accordingly. The last prototype I show you is a face-on globe developed by Daisuke Izawa, a student of the doctoral course. So this theme of the conference is, and this exhibition is AI. So I would say how about the AI. As deep learning or neural networks have pushed AI into new phase. The typical definition of the traditional Turing test that if a device exhibits behavior indistinguishable from a person, you can call it intelligent. May well have become to anthropomorphic now. I think AI is actually other interest. It does not resemble or reflect human intelligence in the way we expect. One of the problem areas that is growing in this field is a communication gap between people and AI. There are various AI robots sold extensively in the market, but many of those who purchase them are disappointed that devices are not as smart as expected. We can make the prototypes to explore the question, how can we use the design to bring a balance between the robot appearance, behavior, and the expectation of the users? Our robot has a sphere-like shape that can shape-shift in order to give a minimal effect to a lifelike impression. By controlling shape, we can capture how people's social behavior change depending on the robot form. Yeah, like this. When you talk to it, it makes a face and appearance of notice your voice and turn to you. What is learned is through the experience of making many different prototypes with various technology research aids, intelligence actually lives in the body. Intelligence is not only in software, the algorithms, but also and importantly in the form, movement, and reactions of the device itself. I am continuing to explore them in my prototyping work for our life of the future when all of objects surrounding us would be intelligent. Thank you.
Thank you, Shunji. I think it's important that he designed the perceived intelligence, illusion of life-likeness. He's not making a machine living, machine intelligent, but the whole design. That reminds me of socially distributed cognitions. Intelligence does not reside in robot or brain. Yeah, do you have any comment? Yeah.
Perceived intelligence is
Yeah.
important keyword for us.
Wonderful. Thank you very much. And also I see some very amazing poetic aesthetics, also kinetic motion, which also connect to Joachim Sauter's lectures, really excite me. So also the great pleasure to be here is meeting the new peoples, which I never saw in the past. And it's a great pleasure to introduce Sarah Jane Pell. And she's of course artist and a scientist, but more than that, she's astronaut candidate, go to the space. Good. So, Sarah?
Thank you so much.
Yeah.
May I get, oh, I have some.
No, it's not the first thing to stop the presentation and start it again. Then you have it on the screen.
What do you mean? I'd like to thank you for having me here. This is my first Ars Electronica, and also to acknowledge the Wurundjeri people of the Kulin Nation, the traditional custodians of the land and waters in which I live and work. My name is Dr. Sarah Jane Pell, and I am interested in extreme performance. When I talk about extreme performance, it's not so much the physical action, but the environment in which we inhabit. Those spaces where our lives are at risk, where we need some additional support and life support in order to perform and express ourselves. So I became a commercial diver to be able to undertake my practice in a body of water. And I began to devise all types of live artworks based on these experiences, those kinds of experiences where I wanted to fly, to create even that poetic illusion that might be, say, Icarus flying too close to the sun, with wings underwater devised by Leonardo da Vinci. I also wanted to talk about this limited breathing space that we had, this precious pocket of air. So I would create live artworks for an audience where I'd have 16 to 20 minutes of air inside a little bubble to create a reflection, a poetic reflection on something of the limited air that we have in our atmosphere. So the politics of sharing air became critical, and I began to devise prototype technologies to do just that. This work was created in the midst of the SARS epidemic, when we were wondering what it was like to be able to share a contaminated air supply. And this gave us 12 hours of an air supply shut off from the rest of the world. I also created live artworks where I inverted the diving experience for a land-based audience. Here you can see my helmet filled with about 30 litres of saline. So the only thing that is holding back that body of water is the tiny little epiglottis at the back of my throat. And if you can remember, we are all mammalian creatures. So when we put our heads underwater, we naturally relax, our heart rate lowers. So in a counterintuitive performance here, I had to fight that natural reaction so that I didn't drown before my audience. And there were all sorts of other prototype technologies, things like how could I externalize what was going on in the internal body by designing a rebreather system based on the bellows of our own lungs and externalizing this and creating gestures where I could offer the audience, say for instance, tiny bits of saliva and drool that had come through my helmet and through my nose. So as you can imagine, I only had ethics clearance to be able to do this work by myself originally as a PhD. And I'll give you some introduction to the type of training and support that was required. I couldn't just undertake this practice as an artist. I had to be trained physically, I had to be trained operationally, I had to work under certain licenses and frameworks. I had to do everything from learning how to jackhammer underwater to be able to work with communications with surface teams in construction environments. And who would have thought that it would enable me the technologies and the skills to be able to sculpt and perform and to move my body and to understand the mechanics of the body using life support systems in these extreme spaces. I'll leave that here and go on, but that was the beginning of this body of work. And it meant from here I could start to work with collaborators and use my practice as a way of critiquing science on a broader scale. I myself was a researcher and the research subject. So I looked at how I could look at the micro scale and the macro scale and use performance to critique that. So working with Symbiotica, the biotechnology and art laboratory, I know they're very well known here at Ars Electronica, we began a collaboration where I literally became the specimen inside the life-size Petri dish. Here I am petrified in a gel medium, and all you can hear is the sonic amplification of my breathing through an umbilical. Additionally, we created a mobile biotechnology and art laboratory. This was taken to ISEA in 2004, where we created a biotech informatic performance state, and we processed people in this life state. We took samples of their DNA, and we psychometrically profiled them we asked them to contribute to a meta-DNA, and we started to critique and analyze systems from science to social utility, to airport and transit and migration systems. But all the while, I was interested in the body, and I placed myself in the environment for over 4 years as a commercial diver in a visible or a black water harbour with no visibility at all. And in doing so, I undertook it as a self-professed residency, if you like. And that whole time, I imagined I was in space. And it didn't matter whether I could see or not see. I was understanding what my body could do in those spaces and places, and I was directed by where the breath was in the body. So this went on for a number of years, and I ended up learning not only how to get along with crews, but also the types of technology so that everything became second nature. We could work in the dark, we could work underwater in the dark, and it was completely second nature. We no longer thought about it. It was a great learning curve because then I could start to begin to work with student groups and trainee astronauts. They train underwater for space. The 1/6 gravity of the moon, for instance, the neutral buoyancy of the underwater environment helps people understand how their bodies move, how they can communicate and prepare for a space mission, or the complexities of those kinds of missions. In this case, we worked with a group over 2 or 3 days with a remote mission control unit who were watching the live comms. But it wasn't enough just to train. I'd been involved in all kinds of simulations for flight, simulations for underwater, but I wanted the real deal. I was ready. So I left the world of diving in the remote west coast of southern Tasmania and 50-knot winds, and working there for 4 years in a black water harbour doing the most unglamorous work you can possibly imagine. Straight to Silicon Valley. Bang. Here we were going to look at exponential technologies and save some of the world's grand challenges. Everything from space to food to water. It was a fantastic transformation. When I came back to Australia, I began exploring possibilities. I worked with the Exertion Games Lab, looking at how could I translate some of this understanding of the body into a robotic technology, an interactive digital system where a land-based person could get it. They could understand something of this movement. And I created a little robot that I called an Explorer Fish, and it had beautiful silicon little tentacles. I created a mother fish, so as you interacted with one, it would command the other fish to dance and move with it. There were a few limitations with the system, particularly because you had the feedback of the body of water moving them, and they didn't have the swarm intelligence to stick together. But it was my dream that they would. So I started to work with understanding the transition from the body underwater, or body on land to underwater, and how I might be able to program these little robots. So I introduced a collaboration with a ballet lab in Melbourne, Australia, and asked these expert dancers if we could capture their motion on land and capture their motion underwater, with the view that when we interacted with these beautiful little robots, perhaps we could create a swarming technology so that as they danced and moved, just like a little fish would school with a big school of fish to mimic a great big mammal, perhaps they would do that with a dancer. There was one limitation. A dancer had a pedestrian logic. They were used to working on land. They weren't divers. So again, I thought it wasn't good enough to just employ. I needed to go. I needed to develop myself. But one of the catchphrases for diving is, remember to get out of diving what you got into diving for. And I got into it because I was interested in performing in space. And the next step up was to go from sea to summit, I thought, en route to space. So I used my opportunity at the Exertion Games Lab to look at how I might track my motion at altitude and understand the pressure underwater and how it might relate to higher altitude as one stepping stone towards my goal. So I set up a project in 2015 where I attempted to summit Mount Everest. And as I was going through the acclimatization and climbing phases, I would send signs of life, that I would make art en route at various waypoints. These waypoints you traverse over and over as you acclimatize, so that I could come back to these spaces to understand something of how we express ourselves in these moments of discovery and extreme exposure. Just like I had been challenged to do so underwater, I was again doing that in space. So by day 11, things weren't going so well. 3 of my crew members got altitude sickness and they had to return. My expedition lead, who I'd been working with for a number of years, contracted dengue fever and had to go back to India. So on my very first Everest attempt, I continued alone with my Sherpa. By day 12, the climbing company, once I'd reached base camp, said to me, "You no longer qualify for a group permit. You need a solo permit. That's $21,000 extra. We don't have Wi-Fi set up yet, but if you could deposit that today, we'll let you continue." So overnight I had a little bit of, actually a cathartic experience. It was rather beautiful. And I realized there, sleeping on the glacier, that it wasn't a mountain that I was attempting to climb at all, that I was there on another body of water. Feeling it respire and creak and move beneath me, I felt instantly connected and instantly at one and at home. In fact, I even felt safe. Now that year, I survived the Nepal earthquakes, but as you can imagine, my entire project and my entire world at that time was really ruptured. Coming back to Earth, as you say, I returned with ever more determination to stick to the mission, to stick to the plan. And in 2016, I began process towards qualification for astronaut selection. So I began training in all kinds of environments, including hyperbaric chambers, undertaking all kinds of aerobatic flight, bringing things that I had from my career, my discipline, including chroma key suits, just in case I would like to work with it later. But understanding something of the difference in perspective and the difference in bodily orientation, and noting too that it's in these moments of being upside down, see even in negative Gs, that it felt like being underwater looking over a coral reef. So on Yuri's Day in 2016, I qualified as a Project ART+COM astronaut candidate. And I began a number of projects in astrobiology, in aeronomy, research to understand the body, but also to undertake spacesuit validation flights. So this is a Final Frontier designed spacesuit, and it needs to be tested at all kinds of altitudes in all kinds of scenarios. My interest was also not only undertaking the science for this mission, but undertaking art and exploring those possibilities. So in this instance, I needed to be able to multitask. So here I was delivering a TEDx talk for TEDx Melbourne while I'm undertaking a spacesuit validation flight. I was getting used to adding complexity to already complex things. In 2016, I also became the simulation astronaut for a European underwater Moon-Mars analog called Project Moonwalk. In this particular instance, I was looking at human-robotic collaboration underwater. My gestures were controlling a robotic assistant called Yemo. Yemo, when we worked in a pool environment where you could see the tools here, Yemo was able to carry tools, undertake certain tasks and so on, and we could look at the cooperation between the two. So in all of these processes, I'm able to extend my understanding of the body, extend my understanding of the tools and the mechanisms for working in these spaces, the kinds of collaborations that I can undertake with technology, and the type of spaces we can inhabit imaginatively and figuratively and physically. So I'm also undertaking sea egress training so that I can land in the water after human spaceflight, and I can survive at sea in these spacesuits as I prepare for a mission where I will be flying to the upper mesosphere using a red camera to document a formation called an occulucent cloud using long-range tomography. These clouds are rather special. They're another body of water. We believe they're tiny ice crystals in the upper mesosphere, and they give us clues about climate science. So as Jacques Arnaud, ethicist to the French Space Agency, said, space represents all, an abstract idea, a physical environment, as well as a tool employed in the social experience. So it's not just all artwork. I have worked, for instance, with agencies such as NASA, exploring a closed-loop habitat system for the moon, collaborating there as the only artist with a group of scientists, of engineers, of policymakers, business people, marketing people, and so on, to create a truly international interdisciplinary approach to a future scenario. This particular project was picked up by, the video is not running there, but it was picked up by NASA headquarters, and many of the recommendations are still being implemented in the precursor missions leading to our vision. Also working with the Japanese Space Agency, they have a fantastic cultural utilization of space program, including, in this instance, a micro-etching of my jewelry breather, which was flown into space as a micro-etching on the end of an antenna for a sprite sat. I could also work with the European Space Agency, developing recommendations and systems and protocols for artists and scientists and ESA engineers to work together. How do we do that? Is it simply about cooperation? Is it collaboration? Is it inspiration? And what are the modes and methodologies for that, and how do we support it? That was a critical program that has led to many outcomes, including residencies and commissions. Working with other groups, there are groups around the world who are using art and science collaboration outside of existing organizations, but working collectively and cooperatively with visions for the future. So one of the things I was still interested in is, how do I understand the body of an astronaut without going? And is that possible? Can I send a toolkit to other astronauts? Can I ask them to mold and shape the feeling that they have when they think of being in space? And if I could receive that, can I cast that in aerogel? So as they gave me their feelings and their feedback, I learnt, in fact, there were many complications about doing that, many personal resistance to that, to sharing that personal data. And again, it was reinforced that I too must go, that I too need to understand the difference in being underwater and being in microgravity from the first-person perspective, that it was not enough to be underwater and just dream it. So another way of extending the collaboration has been to look at, well, how do I take these experiences and share them with an audience? And recently, we looked at developing an avatar or a system so that I could create a mixed reality experience for a land-based audience, so that my body in space could be talking about this switch into another world with a live virtual immersive experience on stage. Additionally, it has been important to not only talk about the practical and the technical, but also to look at how, as artists, we can look at the speculative, to create visions for the future that are not yet imagined, but they are dreamt and they are felt. And this was a science fiction film set on Mars, taking all of the experiences from the rupturing of the earthquake to the work underwater, to imagine what it might be like to inhabit another world. My view for that was that in the end we are all explorer fish, that we are taking those risks out of the world that which we know to become a new species, to become something other. In closing, this is actually a statement I made on a funding application. This, in fact, is my truth and driver. Eventually, I do seek this morphosis to transit from sea to summit to space fluidly and eventually simultaneously. I ask all of you here, will you help me? I have insurance. Unfortunately, the Australia Council said yes. Thank you.
Thank you, Sarah. It's amazing. I never seen the artist scientists went from deep sea to the summit of the mountain, even the space. And it's very, very inspiring to see your body itself is embodied artistic performance. Yes. Thank you very much.
Thank you very much.
So now it's a great pleasure to introduce one of the my colleague, Dr. Daniel Leithinger, and he contributed all the series of shape display, starting from relief, inform, transform. You can see inform in the Ars centers, and also he's becoming professors soon at the University of Colorado Boulders, and so now he's going to talk about his take about how the research of art and science. After Daniel Leithinger, Professor Yoichi Ochai is giving a final talk in these sessions. Then we'd like to go to the discussion. Sorry for your patience, but I'd like to hear from all of you a lot about your experience and the view about how cross-fertilization between disciplines or even space, deep sea, or those environments may impact to shape the new artistic concept. It will be extremely interesting. Ready?
The computer is ready in one moment.
Yes. Machine is ready.
Machine's ready, almost.
But projector is not.
Gut. Vielleicht neu starten? Sorry, just crashed when we plugged in the yeah, futures. Okay. Well, thank you very much, Hiroshi. While we restart the computer, and sorry for that, I had it on my lap and it was working just a moment ago, but I think that's actually a beautiful moment to talk about futures with computers and experience the frustration while doing it. So, should I use this? Okay.
If you want to use this, it's also okay.
So while we wait for Apple to rescue us again, let me just talk briefly about how I came to be here originally. I think I have the very big, let's say, I'm very fortunate to come from very close to Ars Electronica. I grew up here like 30 minutes outside of the city. And I've always had here we go, a very interesting, sorry, let me just restart this real quick. And hopefully everything is coming back. Okay, perfect. Chrome's complaining. Proposing futures. There we go. So now with an image. I've been growing up south of Linz and been living there most of my life up until 2007. And I think I'm gonna, since this is a panel about art and science, and I usually present most of my work in a more scientific context, I really want to talk about what it means to me to present at an art venue and to be inspired by it. So, as said, I've been growing up in a very interesting environment where both in my childhood I didn't have a computer, had the opportunity to roam around in nature a lot. Here's my mom. But then on the other hand, kind of have this weird once a year kind of experience that was very different, and that coming from the outside rather than from the inside also feels very romantic. For instance, having the opportunity to see a performance by Stellark or going into the cave, you know, as a high school kid. Now, now, that leads me to the interesting part that I think this festival has not only the kind of mission to critique the current state, but also to propose a future. I mean, that's you know, both the museum and the festival's mission. And for me, it was always about what will the future of computation be like? How will computers feel to us? Current devices that we interact with are very much with what you see on the right. You know, we have touch screens. What I think a vision of the future could be like is what we see on the left. Physical materials that we can touch, interact with, and other humans that we can be close with. And this contrast between these two kind of brought me closely to what we see in this exhibit at the Ars Electronica Future Lab, which was my very first kind of summer job in 2004, working, you know, as one of the minions that would program in C++ to try and make Gulliver's World happen in the basement of the old museum. Now, while we were you know, coding away, upstairs there was the exhibit by the Tangible Media Group, and here's a very famous example called Sandscape, where you can see Professor Hiroshi Ishii with a sand interface where he can create 3D models, dig around in them, and that's something you can actually see in a retrospective part of the Radical X Atoms exhibit right now as well. So go and see it yourself. But to me, this was really one of the moments where I saw a future that I could believe in that was very different from the computers that I was used to. And so I joined the Tangible Media Group, moved to Cambridge, and started building these shape displays. Here you see the very first one called Relief, which were very much inspired by the idea of building something like the sandbox you just saw, but motorized and able to push back. And I'm just gonna talk very briefly about the shape displays we built. We presented a lot of these in the past, talked about them here at Ars Electronica as well, but I really wanna take a step back and also think about what it means to take them outside of academia and put them in an artistic context and why I think that's important. So you might have seen this graphic before about radical atoms, where going from a purely graphical user interface, the type of flat screens that we're used to today, to handles, physical handles that we can touch, that feel more like clay, for instance, to this completely new material that my colleague Chife and Hiroshi Ishii were talking about earlier, called radical atoms. So this idea of what if we have computation everywhere in the physical world? And what's this idea? Like, how can we go about proposing futures? When I started making these first few shape displays, we had this big problem that we constantly were talking about. What is this hypothetical material? And until you build something that points towards that, you kind of like start thinking in a circle. And until you then expose that to the public, you will again start thinking in a circle. And I think one of the most beautiful, I'm very happy that Christa Sommerer was talking about experiments in art and technology earlier, because one of the very beautiful exhibits that kind of really manifests that was in New York in the Jewish Museum in 1970, so very briefly, after experiments in art and technology, this exhibit called Software, Information Technology, and a New Meaning for Art, and specifically the project that you see on the cover here. So this was before the Media Lab. The Architecture Machine Group under Nicolas Negroponte made this interface called SEEK and was presenting it, and it was a proposed future of a dynamic architecture. And it has this beautiful subtitle of Life in a Computerized Environment. So here are some photographs of that. It was a big box, a big terrarium with a robotic arm above it. Here's Professor Negroponte explaining it to someone. And it had 500 metallized cubes in it, and then a whole bunch of gerbils, these cute little creatures living in there. Now, the main idea behind SEEK was that we could propose how the environment could react and try to adapt to creatures around it, which I think is extremely relevant to this conference theme of artificial intelligence. So the gerbils would roam around and they would topple over little cubes once in a while. And then the computer would try and adapt the environment to their needs and desires. And here you see a photo from the opening. The gerbils are roaming around. I was lucky. It was kind of interesting because when I was looking at this project, I realized it was one of the very, very few projects that this academic group, the Architecture Machine Group, it was their first art project where they had actually exposed it publicly in a artistic context. And it was also one of their last ones. I had a chance to talk to Nicolas Negroponte about it and to a couple of the people that worked on this project. And they were all very ambivalent why they were working on it and what the actual outcome was from it. So Andy Lippman, for instance, still has these cubes in his office. And he's like, we just built it. I have no clue what we did and why we did. But what was amazing about it is, for one, a lot of art critics panned this exhibit because of all its technical problems. And that's something that we experience every day of working with hardware. Of course, things break. The other thing was that because it had living creatures in it, these gerbils, they got sick and they got very sad in this environment. They were like stressed out little creatures. And that has continued to make a statement that has inspired many, many critics to come after that for many years. And I think that is something that would never be possible in a purely academic environment. And so I think this is one glimpse of a future that was envisioned, and that may have turned into a very dystopian future, but because it was built and because it was exposed outside of the kind of circle of your colleagues, it really became a talking point and a concept that has lived on past this very brief exhibit. And so there's a couple of possible futures that we've been thinking about in terms of new dynamic materials. And these are, the very first one, this like very simple idea of physical data representation. So, you know, we have data, we want to have it physical, and we build it so that we can actually touch it. Oh, sorry about that. There we go. Yeah. The other one, very closely linked to dynamic data representation, is to have physical tools that can change how we touch them and how we interact with them. Here is one where we talk about computer-aided design. So trying out how we can physically touch and deform objects. We first explored this as a stop-motion animation, which didn't really get us to a point where we could actually test it before we started building physical tools that we could then expose to the public. And here you see the project Inform, where we built the physical instantiation of this stop-motion project, and we started showing it to people, not only in the lab, but also outside the lab, and got a response to it that to us at the time was pretty overwhelming. And that then led to subsequent projects that we didn't envision in the first place, like, for instance, being able to transform dynamic sculptures on top of a surface like this. The second future that goes beyond this tool-like use is how we can represent our own body through transforming interfaces. What we see here, and that was a quite popular video a while ago, so I'm not going to show all of it, but it's this idea of taking our body, replicating it, and then being able to replicate it over a distance, and thus extending our reach beyond mere physical space. And past that idea of physically being there, also transforming our body along it. So inspired by artists like Stellark, being able to say, not only do I transmit my body, but for instance, I replicate it, I have multiple instantiations, or I completely change it. To have other tools or to have other appendixes and virtual prostheses. Past, just showing data or using a tool, we can also think about the environment as an agent or the physical transformation representing an agent. So here we were showing one of our very first public works after Relief, this table called Transform at the Milano Salone, or Milan Design Week. And here we have a table that has creatures that float on it. Once we approach it, they react to us, the creatures disappear. A physical reaction, in this case the waves appear. And if we interact long enough with the table, it chooses to tell us a story. So it's really this idea of now starting a conversation with this agent and going from just a mere tool to what it means to be in a transforming environment. And here's a very last example of what such a transforming environment could be. The idea again on a similar table like this, saying we could have an environment that knows or senses our intentions and changes dynamically in order to accommodate what our intentions are. Which kind of takes us back again to this idea. Once we have transformation, once we have these new materials, we really go from just a mere physical tool that we can use to living in a computerized environment. And that is something that I think science is unable to answer, and we have to expose ourselves in our projects in order to try and get a glimpse at. So if you have a chance, go over to the Ars Electronica Center, try out one of these possible futures, and let me know what you think is right or wrong with it, and how you would transform it. Thank you very much.
Thank you, Daniel. It's very interesting history because he was in Linz. He was working for Ars Electronica centers as an engineer, and he saw Soundscape many years ago, and inspired, applied to my group, then joined. But he made another significant jump, inventing a genre called a shape display, as you saw, which also opened door to the intermaterial interaction, physical presence, and many interesting artistic or scientific genres. So, last speaker of this session is Professor Yoichi Ochai from Japan and the University of Tsukuba. And he's one of the guys who are very active in the SIGGRAPH, ACM SIGGRAPH. My home is ACM SIG-Chi, but both in the computational academic society keep inventing new kind of technology. But also we are very keen on how to really apply those ideas for the world, including how to inspire the people through the artistic practice. So Yoichi.
Thank you for introducing me, Prof. Ishii. So let me start. And do you know the word jijimuge? Please raise your hand who know these terms. It is in Japanese. I think 3 or 4 guys know this. Because of this is an ancient word. It is used in the 1,200 years ago. So it is really ancient word. So I'd like to talk about that things from the last talk about art and science. So I was working on the independent media artist since when I was graduated from the undergraduate. So I developed many kind of the media artwork in the many situations. So this is my recent work in the 2016. It is exhibited in the Kenpoku Art Museum Festival. So it is an abolished school that is abandoned in the 1 year ago. And also, I'd like to install my artwork there. So this one is kind of the artwork using the soap bubbles. And also, the soap bubbles is usually transparent, so it just passes through the light. And however, by shaking its surface with ultrasonic waves, it can be changed its reflectance on the surface. So it can be used as some screen-like, and also the reflectance of the surface can be controllable, like these things. And the point is, I'd like to show some kind of illusion-like images with these sometimes appears or sometimes disappears, and with using these kind of the liquid materials. And so basically, my background is computer graphics. So using these kind of the techniques, which is some rendering techniques or some controlling techniques of the wavefront, or some kind of the light field techniques to how to control the material appearance of the real world is one of my key thema of my research and also doing the artworks. So I'm using the these kinds of hobby. I love to express these kind of things. And however, the most important thing is how to express these transition between the physical activity of the physical phenomena and also what perception from us. So these kind of things is my largest interest. So, do you know these terms? That is the butterfly dreams. In Japan, it is Kochou no Yume. So it means it is a kind of the ancient story that is Chanzi, who is a Chinese philosopher. When he wake up, so he says that now I don't know whether I was a man dreaming I was a butterfly, or whether I am now a butterfly dreaming I am man. Between a man and a butterfly, there is a necessary distinction. And this is, I think it is a really famous word in Japan, and also in Asian country, that these transition, called the transformation of the material things, is really well known. So I think that this is why, because of the many Asian culture or Japanese researcher doing the transformable things between the like a digital or physical or virtual environment. And also, when I go to when I enter the PhD degree, I'm more doing the holographic things. This one is my 3 years ago work. So also it is exhibited in the Ars Electronica Center. This is a kind of the work which is controlling the object in the air by using the ultrasonic waves. So ultrasonic itself, that is cannot be heard by the human sensory. And also the ultrasonic itself, it can be invisible for the humans. However, the physical object around us is also visible and also tangible. So the main topic is how to control, or how can we treat the physical object without our sensory or without invisible strings or these kind of things. And this one is my last year's work, so working on for the Sigraph 16, and also it got the Stats Prize and the Prix Ars Electronica. So it is a kind of the 3D display or like a 3D haptic graphics, and also it is a tangible graphics in the air. So we employ the femtosecond laser to make the laser-induced plasma. So you can see here the plasmas. So plasma itself is really high temperature, and also please imagine the thunderbolt when it is cloudy or it is rainy day. And however, we use a femtosecond laser. Femtosecond laser is kind of the laser. It has really tiny short pulses, and also it has really high peak intensity. So it can be used as a low consumption energy to render the physical physical plasma, and also we can touch, and also we can interact with the air image. So it excites the gas molecules in the air, and also the excited gas molecules can be emitted the light that can be seen from the human eyes. However, the laser itself, it is the wavelength is infrared laser, so we cannot see the laser itself. However, it is transformed by the air to the visible wavelengths. So as a scientist, it is important things that is a really low consumption energy, because of it can exist with that kind of the small plants. Because of if the like a laser is really strong, that is gonna be burned, or that our finger suddenly burned like that. And also these kind of things. So my key theme of the next challenge towards post-multimedia is how to use out-of-sensory area of the human nature. Actually, the 50 years, we are using the auditory or human sight, like visible light and also the audible sound. However, I think the key theme is how can we use a high intensity wave field or high resolution field or to holographic synthesis by this kind of out of sensory fields. And this is my current work, that is Kai for 2017. And it is a kind of a speaker which can render the audible spots in the air. So without the other point, only on the point of the audible spot, we can hear the sound. However, the other point we cannot hear. It is more precisely than traditional ultrasonic speaker because of it is kind of the holographic synthesis, and also it can be used as really tiny, short areas speakers. So the important things is actually the visible light is really tiny wavelengths in the electrical waves, such like do you know the radio waves, also gamma waves or X-rays. And however, our visible light is really tiny areas in there. And also we believe that the art is like a Euclid space. However, I think the end-to-end AI that is called as a deep learning can be expand our Euclid space to the different positions. And now we are looking for how to interact with the world without the visible feedback. However, this is a homage to the Prof. Ishii because of I love the abacus very much. And also it is with actuation with invisible forces around the everyday object. So actually, I finished the PhD and also the recent years, I'm working on this kind of the computational holographic field design, which is a design of the holographic field of wavelengths and also the using the acoustic waves or optical waves or radio waves, kind of that. And also, when I talk to the Buddhist in Japan, and I talk about these things, so he told me that this is Rijimuge. Rijimuge means that is kind of the relationship between the fields and the space in the Buddhism words. I'm so surprised because of it was considered in 1,000 years ago. And also, recently I'm happened to see the researcher for the dolphins. And also then I changed my mind to the other step, like dolphins can call their name each other. Also, they have their own name, and also they communicate with ultrasonic waves. And also, this is they are called like sonic internet natives, like after million years, so they can telecommunicate each other, and also the 3D recognition with the sound waves. And also, this is my favorite movie. If you see the viewpoint from the other labs without the visible light, we only see that just plate. So other species cannot see the visible light. So it looks like the opening of the space, though they say. I think that what should we do with these kind of the things, and also what we can do next step. And this is my installation that is exhibited in the last year in the Roppongi Hills, that is the highest building in Tokyo. And also, as a media artist, I doing this kind of a sculpture or installation like things with using the like 3D structures that cannot be achieved in without engineering. And also, when I build this kind of the structure, happened to the idea. So we created a sculpture. However, the dolphin is free from gravity. I think that this sculpture is really nice. Really, I love it because of the it released from the gravity, and also the appearance is really it's so cute. However, the dolphin is free from gravity its own, and also they can communicate with 3D acoustic image. So do they need to create physical things? That is the main question. So if you are dolphin, you can transmit the information directly, and that is a three-dimensional image. You have to need the physical things because of the it is like all of you have VR goggles and all of you have 3D recognition cameras. Does it need the physical things? That is one of my recent questions. And so I'm now researching on the how to think about the material side and also the like a non-material side in each other in one research. Like how to think the material side. This is a acoustic lens. It means when pass through the ultrasonic that structure, it's gonna be gather the ultrasonic to the focal point. And also the bottom one is a phase array that is used to make the three-dimensional focal point of the ultrasonic. Also these material side representation and also the non-material side have a really link to each other. And also, the base of the last work, I'm doing the like computational calculation of the like aerial object. Also, this kind of the appearance of the software is described as two patterns. One is described as how to control with the electromagnet, and the other is how to make or how to develop with the material appearance. So actually, this kind of the relationship between the matter and also wave and also the image is one of the key topics of our laboratory, which is optimized by the end-to-end AI. This is my recent SIGGRAPH work. I love this one. And also the kind of the kinetic components. This is last year's work I was presented in the SIGGRAPH Asia. It is a kind of the kinetic sculpture, which is optimized with finite element algorithms, and also it's based on the design and simulation by the computational resources, and also optimized by the software. So when we design the motion, and also it can be fabricated into the physical shapes, it works like we designed, such like a Stanford bunnies use like that, and also can be used to design the free-form structure to shape changing or shape design or the bone of soft robotics. In this puppet, it have a soft robotic bone of the bone by this element. Then, so how can we transform them? Like this is a wave representation, and also the bottom side is a material representation by the 3D printer, and also the left side is kind of the dolphins. A dolphin has a own acoustic lens which can focus the acoustic waves. That is almost the same structure of the right side. That is a 3D printed structure of the acoustic lens. So we have to think the next topic of the human creation versus the data-driven creation. Because of the last 100 or last 2,000 years, we found problem, and also human designers have a solution, and also the production process makes many mass products, and then we ship to the mass market. However, we have to think the now end-to-end production. So the problem and also the data collection is the first step. After that, this kind of software automatically designs the robot or field or acoustic waves or something. And also that is produced by the 3D printers. And also that is more have a diversity. And also that is kind of the more like end to end. And actually, we do the software. Our interest is only for the how we can design the software and also the experience. What the material interface, such like a passive material or active material, doesn't matter. We are looking for the how we can design or how we can construct the software and also experience as a form of data or algorithms. And so finally, the jijimuge means means end to end. So end to end means how we can transform or how the end includes the world itself. So I think many of you know the Matsuo Basho. Matsuo Basho is a Japanese poetry, very famous poetry. And I think many of you, Furuikeya kawazu tobikomu mizu no oto, that is a poetry. It means old pond, frogs jumping, sound of water, just it. However, there is no perspectives. However, we can see, we can imagine, or we can understand what the situation is, or what the what the feelings of the Matsuo Basho is. And also, this kind of the end-to-end is important. And this year, we exhibited our student work, which is AI design, the crosses. This is my favorite designer, the collections. And also the spirits of the talented designer is encoded in his works. I think that this end can be reproduced by the next end. So we collect the data, and also the illustration by the deep learning AI can be achieved. And also we pass through towards the patterner, and also they can make a pattern, and also they can fabricate the cross itself. So these kind of the feedback loops, like a representation towards the next creation, and also we can call each other in other end-to-end AI. Also, we can transform the material worlds through the end-to-end AI. So finally, this is one example we exhibited there, and also it is a kind of the AI-based learning or electromass stimulation-based learning. So it is really difficult to shake your hands 3 times a second and 4 times a second together. And however, with electrical stimulation, it is easy to transform each other. So however, if you pick up these electrodiode, she can be reproduce the process. So it can be next process to learn feedback, build the feedback group in the human and also machine learning. So finally, this kind of the culture, so in the Asian culture, these kind of philosophers, also scientists and also artists transform their perspectives and the consciousness out of body, inside of body, and the element to all, and all to the element. So I think our group called as a digital nature group, so building the feedback groups by the decomposition and the material transformation by the human nature. So I think it should be produced or open up the next term of the art and the science. So thank you so much.
So thank you, Yoichi. I think blurring the boundary between materiality and the image is one of the very exciting stuff. But also you can see he invented a lot of technology, not just solve the problems, but also he's an artist deep in his mind. So speaking technology, science, art, design make a huge difference. So now I'd like to open the discussion to the floor. So all the speakers, please come. It's kind of long run, 3 hours. I can't believe it. Also after this, I have another 2 other sessions. So it's like a long distance run, but hope all the speakers come. Then there's no structures. You have to ask something deep, profound questions in a very concise way. It's not your speech. So who wants to, also microphone? She has a microphone. So who wants to go first? Please mention who you are, from where you are, also whom you want to address the question specifically. Oh, don't be shy. This is Linz. Pardon? Where? Oh, okay. Good. Please come. So, sorry, microphone. We need a microphone. Okay.
It's not a good question. The man with a striped shirt, you know,
Shunji Yamanaka,
yeah. It would be very funny if the shirt is moving too.
Okay, say something. Say something.
Yeah. How can I say? What?
So is this a comments?
Comment? Just comment. Thank you.
Thank you.
Yeah, thank you. Yeah,
Okay.
there's a very simple structure. The impact. Yeah, so the additive manufacturing free-form making is good for such a lifelike movement. Thank you. Yeah.
Okay, next question. Who?
Yes,
Go ahead.
Thank you so much for your fascinating talk.
Who
really
you are?
enjoyed it.
Who you are? What's your name?
My name is Jai Yang.
Johnny Yang. Good. Okay.
Thank you, yes. Thank you for your talk. And this question is not meant to be as a critical comment. I was wondering if any of you can comment on the health implications of your research, particularly, for example, the ultrasonic wave.
Okay, go. Microphone. Microphone. Yes.
You mean the what?
Implication. Yes.
Implication. Yeah, I think that this kind of the ultrasonic waves is actually, どうだろう? I think it's really, I imagine to it is in the space, and also it can be used in the like a pharmacy or medical pharmacy to transport the like water drops into makes a mixture. Well, this kind of the like application as a industrial things, and however, I implied that it can be used as a 3D forms without the physical matters. I think we can only build for that is a sculpture only with physical forms. However, we believe that can be done with invisible like a wave field. So that is my implied things in other the works.
I think his effort to make wave, photons, vibration, air controllable have a tremendous implication for the design and the artistic expression, also dumb practical applications in many places. So next question. Okay. So
Thank you.
Hi, I have a question to Dr. Ochai.
Who you are?
I'm Zhang, I'm from Vietnam.
Okay.
So, hi, thanks a lot for your talk. I've been really super fascinated by what you're doing. I've been following that since last year I was here. And this question might be a little bit silly, but I hope it's a good one. So based on what you've been researching and the development of the technology and also of AI, do you think that one day we would understand how the pyramids in Egypt was built? For example, like with your research on sonic levitation, maybe it could be possible that the pyramids was built that way with the sonic levitation in the past. And the second thing is, you think that the ancient mythology actually were real? Because based on the development nowadays, we might one day become gods, or we have those supernatural possibilities. So what do you think about this?
Microphone. Where's the microphone? Oh, okay, sorry.
Yeah, that does it mean because of the like the butterfly dreams is a really good example, which is everything included everything. That means in the Asian philosophy, and also the many end-to-end AI can be transformed like implicated information towards the different things. And also my my vision is how can we make a transformation or transition each other freely. So I think that is will dramatically changes our philosophy, and also we need to think the other formation between the like everything is static and also everything is like built for the these kind of things will be more fluid like. So that is my one to do things.
Good. I'm a chairperson. I have a power. Next, and next. Who else? Okay, good. Okay, go ahead.
Thank you, everyone. It's a really fascinating project, so really enjoyed listening to all of that. Question for Daniel.
Who you are?
Oh, sorry, I'm Siva from London.
Thank you.
I represent Nesta, the Innovation Foundation in the UK. A question for Daniel. Just wondering, the tables that move up and down, sorry, I don't know the technical terminology, but how far away are they from sort of mainstream adoption and becoming kind of part of our day-to-day lives? Thank you.
Okay, it's on. I think, personally speaking, I think quite far, because when it comes to adopting this type of technology to commercial uses, industry is usually very conservative, and I think that's the biggest point of the work that we're doing. Like, the idea is not so much that we try to improve right now, to like make it smaller and to make it more robust, but to really have a platform where we can show what is a future that is possible with this technology, and is this future desirable or is it not? Is it something that we want to move towards? And I think it's kind of like we have to dance, and if we dance right and convincingly and you know, try to flirt and coax with the people that have the possibility to make this future, actually to adapt it and bring it to market. Because then, you know, right now Coca-Cola, for instance, has installed a huge display on Times Square with over 1,000 moving panels in order to, you know, sell their sugar water. And it's sad, of course, that that's like where we think the future can be, or where the industry thinks like right now that it can be, but it also makes sense for them. So I think very close and very far, but we want to move it closer. Does that make sense?
Great. So we need to transfer a microphone. Do you have still a microphone? Who has a microphone? Okay, great. So.
Hi, I'm Macarena from Chile.
Nice to meet you again.
Yes. Hi. Well, first of all, I think all of your work are very beautiful and very romantic too. And my question is about human relation, because I think the relation with the materia that you're proposing are very romantic and very sensitive. And my question is, for who wants to respond it, is how your work or your relation with the materia can influence in human relation.
I might try and answer that from one of the key points about working in extreme environments is about understanding the poetics of the body in a space. So it becomes in part about understanding the interaction with the technology, but more about understanding our interactions with an environment. They may be virtual or real, actual or illusory. And I think we, as much as we design and create, we are extending ourselves and we are expressing ourselves through the work that we make. And I think most of the work here has a beautiful poetic resonance in whatever way that's being expressed, that is echoing one of the rationales for human exploration and artists in these extreme spaces, and artists in design, artists in technology, artists in engineering.
Good. Also, let's get the comments from Joachim about Zen. Also, you want to, yeah.
Yes, I think you brought up the right term. It's not romantic, it's poetic. And it's a big difference. We heard about, probably you heard about that yesterday.
Oh, yeah.
I think we are living in a time where you have, which is a totally irrational time. You have any kind of information on your fingertip anywhere in the world. And I think as an artist or designer, you have now to find different ways rather than only direct communication. So poetry means that you are working with metaphors, you are working in a more encrypted way, and you as someone who is reading or looking at poetry, you have to decipher it. And deciphering means that you are deeper into the content or deeper into the relation with the artwork than what you have usually on everyday's hand. So I think poetry, and combined with the physical, what we all have seen in our work, so no one is doing purely immaterial work anymore here, so everything is physical, is something which I think meets our desire in the first 2 decades of the new century.
Beautiful
So
answer.
poetry is the new black.
Yes, poetry, not a romanticism.
To be honest, I don't like the term poetry or beautiful or, you know, this sort of, for me, has not so much to do with art. This is more a design term. So I think art, I mean, maybe I'm a little different here, should be more about strong emotions. It should be about provocation, or you talked about disruption.
Yes.
And even, you know,
Yes.
like making you kind of feel a different type of emotion. So I really, maybe I'm conservative, but I do see a strong distinction between art and design. So maybe what you talked about is more a designerly approach for me, while the art approach should have some kind of more transformative, it's hard to describe, but a transformative element that touches other types of emotions, that not necessarily poetic and beautiful.
Okay. Okay.
Sorry.
Yeah, I know.
Because this is totally wrong. So no, poetry comes from art, not from design. You know, design is a function, has a functional, ergonomic, communication point of view. And art is the opposite. And poetry in our history is all about art. We as designers sometimes lend the practice and the strategy of poetry to communicate, but poetry comes from art.
But also I see the point of the Christa. I really like Christophe Visitko or Marcel Duchamp, which wake up the baby sleeping to make a totally new way to see the world, so disturbing. So I think both balance seems to be something interesting. I really like this disagreement. That's the beauty of Ars Electronica. But life is short, time is running out. So now your turn.
Hello. Hi, I'm Leon, just graduated from UDK Berlin with Herr Sauter. And my question is towards you, Professor Ishii.
Okay.
I saw your lab researching a lot about interactive interfaces, which I think is like a translator for us and using our existing sensor to understand information.
Mm-hmm.
So in this sense, do you think like the brain-machine interface would be more like meaningful for us to understand? So what's your comment on this?
No. I think we need some feel of the controls, precision. I like a clay drawing, but all the intermediate technology make huge ambiguity or delay or latency or parallax, for example, touch screen. But using brain is very, very difficult. Always we are constantly thinking or disrupted. So we cannot control the airplane or car or anything, for example. So I do not believe brain-human interface. Also, VR is a completely opposite of our space. But I really appreciate different approach. Some people believe I should think, then should be able to control everything, like amazing paper or building stuff. Some people believe this is a real reality. People love it. You can't get rid of the HMD. That's beautiful. This contrast really creates all the discourse and the disagreement to give a chance of the upheaval.
Thanks.
Okay, any last question? Profound, beautiful, or disturbing question? Okay, great. Yeah. Oh, yeah.
I tried to make it short. Jill Scott from Switzerland, Australia, mixed media artist. Okay, so my question is actually about the inspiration from nature, which obviously you all are wonderfully experiencing. And my question is about, as we know in biology, you have this incredible interdependence in nature that abstracting from it tends to actually misrepresent it. So I'm very interested in how some of you feel about that, whether in fact you feel that your work sort of ties a loop, back to the public. And so it's a public appreciation question that I'm asking. How do you feel about your work in terms of increasing awareness about nature and nature's processes?
Who wants to go? Nature. Okay, Christa.
Maybe very briefly, thanks, Jill, for bringing this up. I think this is a very important question. We need to sort of, and that's a bit related to this mirror neuron idea, Whatever we see is being mirrored in our brain. So it's all about this relationship between you and nature, you and the others, you and yourself even. So I think good art for me is touching this kind of mirror, that you see yourself, your emotion in that object or in that kind of device or whatever it is, or artwork. And if that works, if that emotional connection is there, I think then it's good art, it's good design, it's good science.
I also like... Another question?
No, I think some other people have something to say about that question. I think a few others have something to say about that question.
Really quickly, I've been a big advocate that art does more than illustrate science. We disrupt, we invent, we research, we twist things around. That it is poetics and aesthetics, and it is an important distinction. So yes, we are representing the environment, but we may be disrupting it. We may be corrupting it. We may be seducing it. You know, we're doing all kinds of things, and those relationships are not static, and that's important.
I want to design, or I want to explore next generation of the human beings in our digital natures, and towards the like dolphins. So dolphins like just singing in the waves, and also our circumstances will be transformed each other, and just like a fluid and just like a waves. So we becomes like this kind of the species. I'd like to make it all humans towards like this kind of a singer in the waves.
Yeah, I'm an industrial designer. I always thinking of, every people thought I am always thinking about the artifact, but in fact, I am always thinking about the human. Yeah, that relationship is the design itself. So for me, human is the last frontier for exploring the nature itself.
I think that's a good concluding remarks. I'd like to thank again for the amazing speaker, which inspired me a lot. Also go deeper. And also I like poems that many people talk about. Abstraction, enough room to read between text, lines, based on imagination. That's the beauty of the art for me. Also science, mathematics, formula. You have to really analyze data, then formulate using mathematical abstract expression. Then let people help answer the question, what if? So both have something in common, but also very different. So I think that's the beauty, and hope we can really continue the effort of cross-fertilizations between these genre or space, but also being not only the artist or scientist, but becoming the all. Then do the effort, enjoy the translation among all the dimensions of art, design, and science, and technology. Also, I'd like to thank you to the people who participated in the discussion, also Carla and all the people who helped this amazing symposium happen. So thank you very much. Thank you very much. So good news, now lunch is waiting for you. Bad news, I have to start another session in 15 minutes for 2 hours, talk about swarm intelligence. If you're not hungry and tired, you can keep sitting, join another session in 15 minutes. Thanks again, and we're happy to answer any question personally, and thank you very much.